All right, for this demonstration, we have a Gauss gun. Now this is different from a railgun, and usually when people see this, they go, oh, it's a railgun, and most people are familiar with the railgun, like the US Navy has railguns and stuff like that. This is not a railgun, this is a Gauss gun. The main difference between a Gauss gun and a railgun is a railgun uses electricity, and therefore the magnetism that comes off of that electricity to power it. So it's literally electromagnetic gun, so to speak. Whereas the Gauss gun is really just magnets. Now the confusion really comes in that this one here literally just has 4 magnets. You could easily replace them with electromagnets and achieve really something better than this. But it would still be a Gauss gun as opposed to a railgun. A railgun has this whole flux thing going on that we're not talking about. But this is pretty easy to understand. I have magnets here, I've got 4 magnets. And they're set up on this rail, and we can see that I have these iron spheres on each magnet. And this is kind of like Newton's cradle, that if I roll one sphere in, then one will come out the other side. The reason why I want 2 is because these magnets are pretty strong, and if I rolled one in, this one would come out, but the magnetic field's so strong that it wouldn't get very far before it reversed direction and came back. So I gotta have 2 to get a little bit more space so that I can make it accelerate. And what's going to happen here is I'm going to take one of these spheres, put it right here, and I'm going to let it slowly roll. I'm going to start with an incline this way very purposely, and then I'll slowly tip it so that it starts to roll down the ramp. And as it rolls, you'll notice that it accelerates as it gets closer to the magnet, because the magnet will attract it. And they're iron, they're not magnets themselves, but they'll become attracted, you know, when you put them in a magnetic field, all those domains aligning and so forth. So when that happens, you'll notice that it will accelerate up to the magnet, which will cause this ball to bounce out, which gets accelerated to this one, and so on and so forth, off the end. And so each magnet increases the speed by a little bit. So this is, again, not dangerous, but I want you to put your eye out. So the key is to notice how slowly it's moving at first, and how quickly we can end up with. So you can imagine that if this was like a gun, first of all, this would be terrible to reload, but second of all, you would notice that if you fired it like a conventional weapon, you could actually use these magnets to accelerate it much faster. All right, so ready? There we go. So I'm going to slowly tip it. All right, so you're about level. And that's it. That's the Gauss gun.